Let's take a look at the double angle formulas. We have for sine that the sine of 2 theta is equal to 2 times sine theta times cosine theta. So what that does is that allows us to rewrite, if we have sine of 2 theta in a problem, we could rewrite it as 2 times sine theta cosine theta. Something that would be handy maybe working an identity or working a problem where maybe we couldn't solve the sine of 2 theta very easy, but we could figure out what theta was equal to and just plug it in here and work it out faster. Alright, for cosine of 2 theta, that's equal to 3 different things. So we have a lot of choices for cosine of 2 theta, and you always choose the formula that is most appropriate to whatever you're working. One of the formulas is cosine squared theta minus sine squared theta. Another one is 1 minus 2 sine squared theta. And the last double angle formula for cosine is 2 cosine squared theta minus 1. And so again, it depends on what problem we're working and what's given in the problem as to which formula that we use. These formulas are also used in calculus whenever we have to do maybe an integral or something that requires us to use trig functions, and sometimes when we do integrals they're pretty tough, so we do a substitution, we change it around and make it look like something else so that we can work with it. There is a double angle formula for tangent. The tangent of 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. Alright, so how could we use these formulas to help us solve something? Let's say that we were given that the sine of theta is equal to 3/5 and theta is greater than pi over 2 but less than pi. Alright, so let's first figure out, where is theta located? Theta is in the greater than pi over 2 but less than pi. So we're in the second quadrant. Alright, we may have to use that, may or may not have to use that, but it's always important we understand where our angle measures are. Now, given this information, what if we were asked to find the sine of 2 theta? So we're able to find the sine of 2 theta by just having what the sine of theta is equal to. And you say, well, how is that? Well, we have a formula up here. Sine of 2 theta equals 2 times sine of theta times cosine of theta. We were given sine of theta in the problem. Let's figure out what cosine of theta is using x, y, and r. Remember, sine of theta is y over r, so that means y equals 3 and r equals 5. And since we're in the second quadrant, keep in mind that if we do solve for x, then it needs to be negative. And we do have to solve for x because we want to know the cosine of theta for our formula. So let's figure out what the cosine of theta would be equal to. The cosine of theta is equal to x over r. We have y over r. So let's figure out what x is using x squared plus y squared equals r squared. Alright, so I have x squared plus 3 squared equals 5 squared. Or x squared plus 9 equals 25. So x squared is equal to 16. Solve for x. X equals plus or minus 4. We're in the second quadrant, so x is going to be a negative 4. Alright, so what does that mean cosine of theta is equal to? Negative 4 over 5. So now we can find the sine of 2 theta. The sine of 2 theta is equal to 2 times sine of theta was 3/5. Cosine of theta was negative 4/5. 2 times 3 is 6 times 4, or you can think of it like negative 4. That's going to be a negative 24 over 5 times 5 is 25. Now, don't worry about which quadrant sine of 2 theta is in. Because, logic would probably lead you to think that, okay, I've always been told sine is positive in the second quadrant. So that means that when I work out the sine of 2 theta, I should get a positive answer, right? No. Because it depends on sine and cosine. So when you start plugging stuff in, just take the positive or negative sign that you get with your final answer. As long as you don't mess up plugging in the positive or negative terms and you understand how to multiply them, just take the answer. Don't worry about the salty sea chart at the end of the problem. We might need to use that to figure out where positive and negatives are at the beginning of the problem, but not at the end. All right, let's for the same problem, let's find cosine of 2 theta. We have 3 choices for cosine of 2 theta. I would always suggest using the given information, not information that you had to work out and figure out if you can, because we know that the sine of theta is 3/5. That was given in the problem. Now I might have messed up on the cosine of theta. I don't think I did, but if I did and I used that value, then I'm for sure going to get this problem wrong. So what I always suggest doing is just use the given information whenever you can. We do have a formula that just has sine and it doesn't have sine and cosine. That formula is 1 minus 2 sine squared theta. So if I use this formula and I plug in 3/5 in for sine theta and square it, I should be able to get my answer. Alright, so this is going to be 1 minus 2 times sine is 3/5. So when you plug in the 3/5 though, since it was squared here, make sure that you square that. Alright, so that's 1 minus 2 times 9/25, or 1 minus 18/25. And what is 1? 1 is 25 over 25. So you have 25 over 25 minus 18 over 25. It's going to be 7 over 25. So the cosine of 2 theta is equal to 7 over 25. Alright, let's try another problem. So let's say that we were given tangent of theta is equal to 1/2 when theta is greater than pi and less than 3 pi over 2. Let's find the sine of 2 theta and the cosine of 2 theta. Alright, we only have one choice for a formula for the sine of 2 theta, and that is sine of 2 theta equals 2 sine of theta times cosine of theta. Alright, where is theta located? Greater than pi, less than 3 pi over 2. So we're right here. In that quadrant, x's are negative and y's are negative. Sine is y over x. So what is y equal to? -1, and x is equal to -2. That's how we get a positive 1/2 there. Now, to work out this first problem here, this sine of 2 theta, I need sine of theta and cosine of theta. I'm not given either one of those, so I need to figure both of those out. Sine of theta is going to be y over r. Cosine of theta is going to be x over r. I have y and x, I just don't have r, so let's solve for it. X squared plus y squared equals r squared. So 4 plus 1 equals r squared. So r squared equals 5, which means that r is going to be equal to the square root of 5. So sine of theta is -1 over the square root of 5, which when you rationalize you get negative square root of 5 over 5. Okay, and cosine is x over r, so x was negative 2. So you have negative 2 over the square root of 5, or negative 2 square roots of 5 over 5 when you rationalize. Now to solve for the sine of 2 theta, that's going to be 2 times sine of theta is negative square root of 5 over 5 times cosine of theta, that's negative 2 square root of 5 over 5. So I need to say 2 times negative 2, negative square root of 5 times square root of 5, and then multiply those together. So we have two negative signs, that's just going to make a positive. 2 times 2 times 5. 4 times 5 is 20, over 5 times 5 is 25. Simplify that, you can divide both of those by 5, and you get 4/5. Alright. Now let's do cosine of 2 theta. We have three choices for cosine of 2 theta. Since we were not given sine or cosine in the problem, we had to figure them out. You can choose any formula that you want. Alright, I'm going to choose the last formula, just to choose the last one. And it was 2 cosine squared theta minus 1. Alright, so I need to know what cosine of theta is equal to so I can plug it in. Cosine of theta was equal to negative 2 square roots of 5 over 5. So that's what I'm going to square. And then I'm going to subtract 1. Alright, so I have 2 times negative 2 times negative 2 is 4. And square root of 5 times square root of 5 is 5. So positive 4 times positive 5 is 20 over 5 times 5, 25 minus 1. Alright, that's going to be 40 over 25 minus 1. The common denominator would be 25. So you have 40 over 25 minus 25 over 25. So that's going to be 15 over 25, which reduces to 3 over 5, or 3/5.